All right, today we're going to tackle a huge question that pops up all the time in the world of data engineering. How is Apache Kafka so ridiculously fast? Let's peel back the layers and see what's really going on under the hood. So, what is the secret here? Is it some kind of crazy, super complex algorithm? Is it just magic? I mean, when you look at the performance numbers, it's really easy to let your mind go there. But the truth is, it's not magic at all. The real answer is actually way smarter, way more elegant. Kafka's speed comes from a really deep understanding of how computers actually work from the ground up. It's all about working with the hardware and the operating system, not fighting against them. It's just brilliant engineering. Okay, so first things first, we've got to be really clear on what we even mean when we say fast. For Kafka, fast isn't about latency. It's about massive, incredible throughput. You can think of it like this. Imagine a huge pipe for moving water. The wider that pipe, the more water can flow through at any given time. Well, Kafka is basically a giant pipe, but for data. So how does it pull this off? Well, let's dive into the first big secret. And this one is all about busting a myth that almost everyone in tech just takes for granted. You've heard this a million times, right? It's like rule number one of computing. Memory is fast, disks are slow. And you know, this one single idea dictates how so many of our applications are designed. But what if that's a massive oversimplification? The reality is, how fast a disk is depends entirely on how you're accessing the data. And that is the fundamental insight that the creators of Kafka built the whole system around. Okay, so it all boils down to two different ways of getting data. First, you've got random access. Think of this like a record player needle having to jump all over a vinyl record to play little snippets of different songs. That physical movement of the drive's arm seeking a new location, it's just painfully slow. But then you have sequential access. This is like putting the needle down at the beginning of the record and just letting it play all the way through. The arm moves smoothly, continuously reading one block of data after another. And this is incredibly fast. And look, the difference in performance here is not small. It is absolutely staggering. We're talking about sequential writes that can hit, say, 600 megabytes per second on modern disks. Random writes, they might crawl along at 0.1 megabytes per second. That's not just a bit faster, that's thousands of times faster. It's a completely different league. So how does Kafka force this super fast sequential pattern all the time? Well, it's because of its core data structure, the append-only log. It's just what it sounds like. Every new piece of data is simply tacked on to the very end of the file. That's it. It's so simple, but by design, it means every single write is sequential. And just like that, Kafka turns what we all thought was a slow hard drive into an absolute beast for ingesting data. Okay, so that's how Kafka gets data onto the disk so quickly. But that's only half the story, right? You also have to get that data off the disk and send it out over the network to consumers. And this is where we find our second big secret. And it's all about avoiding a ton of hidden, wasteful work. See, the normal way of sending a file from disk to the network is, frankly, a little absurd. First, the operating system copies the data from the disk into its own memory cache. That's copy number one. Then it copies it from there into your application's memory. That's copy two. Then your application has to copy it again into something called a socket buffer, copy three. And finally, that buffer gets copied to the network card to be sent out. That's 4 copies. I mean, think about that. That is 4 separate copies of the exact same piece of data. And the whole time your main CPU is getting bogged down, just shuffling all this data around. When you're trying to achieve massive throughput, this overhead is an absolute performance killer. This is where Kafka gets really, really clever. It uses a principle called zero copy. It leverages a special command in the operating system that basically tells it, hey, you see that data in your page cache? Just send it directly to the network card. Don't even bother giving it to my application. The application gets completely bypassed. We go from 4 copies all the way down to just 1. And believe it or not, it gets even better than that. That last remaining copy, from the OS cache to the network card, it's often handled by a piece of hardware called a DMA controller. That stands for Direct Memory Access. This means a specialized chip does the copying without bothering the main CPU at all. The CPU is completely free to go do other important things. It is the ultimate efficiency boost. So when you put these two big ideas together, the genius of it becomes so clear. Kafka's speed isn't some secret algorithm or some kind of magic. It's just a deep, fundamental respect for the physics of how computers and hardware actually work. It really all boils down to two powerful ideas. First, embracing sequential I/O to turn slow disks into high-speed lanes for data. And second, using zero copy to cut out all the wasteful, unnecessary data shuffling between the disk and the network. That's it. Those are the cornerstones of its incredible performance. You know, this whole thing really points to a much bigger idea. Kafka's speed isn't magic. It's just smart engineering that understands the system all the way down to the metal. And it really makes you wonder, doesn't it? What other systems out there that we all just assume are slow are actually just one clever design choice away from being incredibly fast? That's definitely something to think about.